Welcome to another edition of A for A levels from my tutor. Today we're going to do 9709 AS Math 2021 February-March paper. Okay, let's start. The first question is find the first three terms in the expansion in the ascending powers of x. So this is your normal expansion of a binomial expansion. One plus x to the power of 5 equal 1 plus 1 x plus 5 to x squared. Okay, 1 plus 5x plus 10x squared. That's it. Find the first three terms in the expansion in ascending powers of x of 1 minus 2x to the power 6. 1 minus 2x power 6 equals to 1 plus 1 minus 2x plus 2 minus 2x squared. 1 plus 6 times minus 2 is minus 12x plus 2 is 6 times 5 over 2 is 15, 4x squared. Okay, and the answer is 1 minus 12x. 15 times 4 is 60 plus 60x squared. It's the solution. Hence, find the coefficient of x squared in the expansion 1 plus x to the power 5 times 1 minus 2x to the power 6. So what I'm going to do is I'm going to write down the solution for the first one. It's 1 plus 5x plus 10x squared minus 12x plus 60x squared. So I'm interested in the term of x squared. So I will take this term times by 60x squared. 60x squared. This term times by 12x minus 60x squared. And this term times 1 plus 10x squared. So the answer is 10x squared and the coefficient. Okay, next question 2. By using suitable substitution, solve the equation. So what I'm going to do is I'm going to substitute y with 2x minus 3. This will give you a clearer picture. So this becomes y squared minus 4 over y squared minus 3 equals 0. Multiplying by y squared, you get y to the power of 4 squared minus 4 equals 0. Factorizing in y squared. So you have minus 4 here, you have plus. Okay. So this y squared plus 1 cannot be 0, but y squared minus 4 equals 0. Y squared equals to 4. Y equals to 2. Or y equals to minus 2. Now, you're not finding y, you're finding x. So you need to substitute y equals to 2x minus 3 back into the equation. And you have x equals 5 over 2. That's one solution. And x equals to half. That's the other solution. Question 3, trigonometrical equation. Solve the equation. You're going to multiply both sides by tangent theta minus 2 sine theta. So on the left side of this equation is still tangent theta plus 2 sine theta. On the right side, it is 3 times tangent theta minus 2 sine theta. So 3 tangent theta minus 6 sine theta. Okay, so you have 8 sine theta equals to 2 tangent theta. Substituting your identity of tangent theta, you get 2 sine theta over cos. Multiplying by cos theta equals to 2 sine theta. So you need to factorize. Don't divide by sine theta. If you divide by sine theta, you're gonna be short of solutions. So here you have sine theta equals 0 or cos theta equals to 1/4. Here both is possible. So when sine theta equals 0, theta is between 0 and 180. Those 0 and 180 is not possible. So this sine theta equals 0 has no solution. Okay? And cos theta equals to quarter. Theta is cos 1/4. Okay, so answer is 75.5 degrees. 75.5 degrees. Okay, good. Let's go to the next question. Line has equation y equals 3x plus k and a curve has equation y equals x squared plus kx plus 6, where k is a constant. Find the set of values of k which the line and the curve have 2 distinct points of intersection. So this is a problem of lines of intersection and your quadratics. So substituting y equals to 3x plus k, you get 3x plus k x squared plus kx plus 6. X squared plus k minus 3x plus 6 minus k. I'm going to put it in the bracket so it's clearer for you all to see. So now, yes, intersect at 2 distinct points. So the discriminant b squared minus 4ac is larger than 0. A minus 3 squared minus 4 times 1 times 6 minus k is larger than 0. So I'm going to expand quickly. That's 9 minus 24 plus 4k larger than 0. So you have k squared minus 2k minus 15 by factorizing plus 3 k minus 5 larger than 0. So if it is larger than 0, then the values of k are beyond the 2 roots. So k is smaller than minus 3 and k is larger than 5. That's the solution. Okay. Another new question starting from 2020. Graph transformation. In the diagram, the graph of y equals fx is shown with solid lines. The graph shown with broken lines is a transformation of y equals to 5x. Describe fully the 2 single transformation y equals to fx that have been combined to give the resulting transformation. If you look at the shape of the image, it will be, you see here and here, is a stretch from 1 unit to 3 units. So first you have to do a vertical stretch by a factor of 3 invariant line x-axis. So after this stretch, it will 2 will move to 6. This point will move up by 3, and this one also move to 6. So after the stretch, you have okay. This is the first transformation. Second transformation, of course, is a translation, a horizontal translation by 1, 2, 3, 4 units by plus 4. Okay, that's it. So state in the term of y equals f and x, the equation of graph shown with broken lines. So you have a stretch. The stretch will be f1 over ax, vertical stretch. So y equals to f. Stretch factor is 3, it will be 1 over 3x. Put it in grid so it's clearer for you to see. A horizontal translation be minus 4. That's it. That is your solution. Okay. Next question. Question 6. Curve is such that dy dx equals 6 over 3x minus 2 cubed, and A lies on the curve. Point is moving along the curve, and at A, the y-coordinate point is increasing at 3 units per second. So this one will give you dy over dt equals to 3. And the rate of increase of A of the x coordinate of the point. So they ask you to find what is dx over dt. Writing the related rate of change equals to dy over dx times dx over dt. So this will be 3. This is 6 over 3x minus 2 cube times dx over dt. Now at A, the value of x is 1. This is 3 equals to 6 times dx over dt, and therefore dx over dt 2 unit second. Okay, that's all the question. Function f and g are defined as follows. Fx is x squared plus 2x plus 3. X domain is x smaller or equal to -1. Gx equals 2x plus 1 for the domain x larger than or equal to -1. Express fx in the form, the complete square form. So you have fx equals to x plus 1 to half square minus this one square plus 3. So this complete square is all quite simple. That's it. Okay, next. Find an expression of the inverse function of x. So we're going to do a y x interchange. So y equals to x plus 1 square plus 2. Oops. It seems to have dropped down. X equals to y plus 1 square plus 2. X minus 2. Y plus 1 equals to. Always when you square root, there's a plus and minus. I'll explain to you when is it minus and when is it plus. Okay, so there is basically a very simple rule to follow. Okay, this graph here, x plus 1 square, this graph here has a minimum point of -1, 2. But the domain is x smaller equal to -1. Okay. Now, it will only be this left side of the graph. So when it's on the left of the graph, the general rule is to take the negative. Okay, so this f inverse x is minus x minus 2 minus 1. You can also see that the domain is a negative value. So therefore, only with negative, only you can be, the inverse function can have a range of a negative value. Okay, so the domain of the function is the range of the inverse function. Okay, solve the equation g of x equals to 13. So usually what I will teach is you use the inverse function that you have found, the inverse function both sides x, inverse function both sides 13. So f inverse f, you should get just x. So gx is f 13. This way, you don't have to find the inverse function. So it's gx, 2x plus 1. Minus 2 minus 1. Okay, so you have 2x equals to minus 11 minus 2. X equals to minus 1 minus half. That is the solution. Okay, so if you want to find the composite function, this is what you get. I'll show you. G of x, 2x squared plus 2x plus 3. So it will be x squared plus 2x plus 3 2x squared or x plus 6 plus 1 plus 7 minus 13 minus 6 equals 0. So you have x squared plus 2x minus 3. So you have x plus 3, x minus 1. Wait. I have got this wrong. No, it's correct. So here you have x equals minus 3 and x equals to 1. Sometimes if you do it this way, it does not really work. In verse 13. I think this is wrong. It's correct. X plus 1 square is minus 2 and then minus 1. 13. Okay. So in this question, this does not work. I will come back to that later. So the solution in this question is because x is smaller than, for the domain of G, for the domain of x smaller than -1, so x is equals to minus 3. That is the solution. Okay, find, oops, this is again problem. Now, question 8. The points A, B, and C are on the circumference of a circle. This is also another question, new question starting from 2020 on circles. Find an equation of a circle. So the circle would have equation x minus a squared plus y minus b squared equals to r squared, where the point AB is the center of the circle and r is the radius. Find an equation of the circle. So this is the circle, and there are 3 points. A, B, and C. A, B, and C are on the circumference of the circle. So, likely you must find what is A, B, and R by substituting the 3 points on the circle, so that to generate 3 equations. So you have 7 minus A square plus 1 minus B square equals R square. Second equation, 7 minus a square plus 9 minus b square equals r square. This is the first equation. This is the second equation. Now, if you notice, they've given 2 points where the x coordinate is the same, 2 points where the y coordinate is the same. There's a reason why. It's because you can eliminate. So if you take equation 2 minus equation 1, you eliminate the a and the r. So you have 9 minus b square minus 1 minus b square equals 0. So you have 81 plus 18b plus b square minus 1 minus 2b gives you plus 2b minus b square equals 0. So you come and you will have an equation b only. So this is 20b equals to minus 80 is minus 4. Okay. Now if you take equation 2 minus equation 3, you get 7 minus a square minus 1 minus a square 0. Here you get 49 minus 14a plus a square minus 1 minus 2a is plus 2a minus a square equals 0. Again, you can cancel off the a square. And you get 49 minus 1 is 48. This is minus 14. Oops. 9 minus b. Made a mistake here. This is minus 18. This is minus 18. So you have minus 16b. So b is 5. Sometimes if you move along, you will notice some mistakes. So this is minus 12a equals 0. 12a equals 48. A is also equal to 4. So by substituting the value of a and b into equation 1, you get 7 minus 4 square plus 1 minus 5 square equals to r square. So this is 3, this is 4, so r is 5. And you have it. Your equation is x minus 4 square plus y minus 5 square equals to 25. That is your answer. Find an equation of tangent to the circle at B. So you have B. You have the center is 4, 5. And B is 7, 9. 7, 9. And this radius and the tangent is perpendicular. So the gradient of the center with B is 9 minus 5 over 7 minus 4 equals to 4.3. So the gradient of the tangent is minus 3 over 4, which is the negative reciprocal. So the equation of the tangent is equals is y minus y1 equals to mx minus x1. So this is the point B, y minus 9 minus 3 over 4 x minus 7 So you have it, y equals to minus 3 over 4x. This is 21 over 4 plus 9. 21 plus 36 is 57. You have it. That's the solution. The first term of a progression is cos theta. Now, theta lies in the first quadrant, 0 and half pi. For the case where the progression is geometric, the sum to infinity is 1 over cos. They show that the second term is cos theta sine square theta. So sum infinity. So you're given the first term is cos theta. Sum of infinity is 1 over cos theta. Is 1 minus r. Cross multiplying, you get 1 minus r equals to cos square theta. R equals to 1 minus cos square theta. Okay. So the second term, T2, is the first term, which is cos theta, times the ratio. So this 1 minus cos square theta, I forgot, using the first identity, sine square theta plus cos square theta equals to 1. So this 1 minus cos square theta will be sine square theta. So this is cos theta sine square theta. That's it. And the sum of the first 12 terms when theta is 1 over 3 pi, giving your answer correct the 4 significant figures. So T12 cos theta square theta power of 12 minus 1. This will be cos 3 pi square 1 over 3 pi 11. So cos 1 over 3 pi is half. Sine 1 over 3 pi is root 3 over 2 is square. You get 3 over 4 to the power of 11. So you're also required to know the common angles, the value of sine, cosine, tangent of the common angles. So the four significant figures, 0.0, 2, 1, 1. Okay. For the case where the progressions for the first two terms are again cos theta and cos theta sine square theta respectively, find the 85th term. So the difference will be the second term minus the first term. Factorizing, you get cos theta. Sine square using the first identity again. Sine square theta minus 1 will be minus cos square theta. So this is the difference is minus cos cube theta. So you're asked to find the 85th term, which will be the first term plus 84 times the difference. Plus 1 over 3 plus 84 minus cos cube 1 over 3 pi. Cos 1 over 3 pi again is half. Cos cube 1 over 3 pi is half cube, will be minus 1 over 8. So this can be divided by 4, which is 21. So it is half minus 21 over 2, which is minus 20 over 2, which is minus 10. Question time. The diagram shows a sector ABC which is part of a circle of radius A. The points D and E lie on AB and AC respectively and are such that ADAE equals to K. The line DE divides the sector into two regions which are equal in area. For the case where angle BAC is 1/6 pi, find K to 4 significant figures. So this angle is 1/3 pi. Like 1/3 pi in this question. Okay, let's see. K is smaller than 1. So read the question properly. So they say they divide the sector into two regions which are equal. So triangle ADE will be half the sector, the area of sector ABC. So using a formula for triangle half AB sine C, so it is half K, which is these two sides, times sine of the angle, which is 1/3 pi, equals to half R square, which is A square, theta. So here you have K square A square over 2 times sine 1/3 pi is √3/2 equals to pi A square over 6. Okay, you can cancel off the A. K square equals to, we can cancel this, we get 3. So 2 pi 3√3. So K is a positive value. K equals to square root of your answer, which is 2 pi 3 times √3 square root the whole thing. 2, 4. Now they like 4 significant figures. 1.010. Just careful. Not 3, you must put the 0 in to make it 4. For the general case in which BAC equals theta radians, it is given that theta or sine theta is more than, find the set of possible values of K. Okay, continuing from previous question, K square A square over 2 times sine theta. Half A square theta. So you cancel this. So you have K square over 2 equals to, oh, no need 2 already. This is can be cancelled off. Just K square. Just let me confirm. Okay, correct. Theta over sine theta. Now you're given theta or sine theta is more than 1. So K square is more than 1. K square minus 1 more than 0. This becomes a quadratic inequality. K minus 1 plus 1. Again, this is beyond the 2 roots, smaller than minus 1, larger than 1. That's the solution. Okay, we have come to the last question. The diagram shows the curve with equation y equals to 9x power minus half minus 4x power minus 3 over 2. The curve crosses the x-axis at a point A. Find x coordinate of A. So here y equals to 0. So you can always factor out the lower power is this, minus 3 over 2. We will factor x power minus 3 over 2. Yeah, this is x minus 4. So this is not 0. Cannot be 0. So x equals to 4. And the equation of the tangent, the curve at A. So here you got to differentiate to find the equation, the gradient at A. 9 is half x minus 3 over 2 plus 4 times 3 over 2 is 6. X minus 5 over 2. X is 4. dy over dx equals 9. 4 to the power minus 3 over 2. 2 to the power minus 3 is 1 over 8. Minus 1 over 16. 2 to the power 5 is 32. So this is 6 over 32. So the gradient is 5 over 16 minus 1 over 16 is 4 over 16 is 1/4. So this is 9 over 4. Gradient is 9 over 4. So in x equals to 4, y is so 4 to the power minus half is 2. Plus, it's not plus, it's minus. Okay, this is not minus. This is just, there's no half. Get myself mixed up sometimes. Stop here. Okay. So it's just half plus minus 4. X to the power minus 3 over 4 to the power minus 3 over 2. So 1 over 8. Equals 0. Oh, of course, at AY is 0. So the equation of tangent y minus y1 equals to mx minus x1 y equal to okay 9 over 4 x minus y equals to 9x minus 9. So that's the equation of the tangent. Find the x coordinate of the maximum point of the curve. So the maximum point, your differentiation or differential is 0. So dy over dx so it's a dy dx. So you have, again, you factorize the lower term. 9 times half x minus 5 over 2. This is half minus half x. So you will have minus x. So I put a minus here. So you get x minus 12. Oh, this cannot be 0, so x is 12. X coordinate is 12, and that's the answer. Find the area of the region bounded by the curve, the x-axis, and the line x equals to 9. So it must be some this region. Okay, this is quite a direct question. So you have to integrate between 4 and 9. So area 4, 9. Take out the 9. It's x minus half plus 4x minus 3 over 2 x equals to 9. This is 9. Add the power by 1, you get half over the power plus. Add the power by half, you get minus half. Add the power by 1, sorry, and over minus half. 9, 4. Okay. Substituting. I'm going to simplify first. So this is 2x to the power half plus minus 8 over x to the power half. See, it will give you a perfect square 9 and 4 because both are square roots. 9x, 9 to the power square root of 9 is 3, 2 times 3 is 6 minus 8 over 3 minus square root of 4 is 2, 2 times 2 is 4 minus 8 over 2 minus 4, so this is 0. So this is equal to 6 times 3, this is 10 over 3 times 9, get 30 unit. That is your answer. And there you have it. If you like this lesson today, press the subscribe button and like. If you want the paper, I will. You can put in a comment, put in your email. I will email it to you. Okay, for now, thanks and see you next time.